Okay, we have a physics problem that's in chapter 6, problem 59. We have a man, it says a man on an ice pond, which is has a radius of 5 meters. And it gives us the weight of the man of 730 newtons. And it tells us that a man throws a book, and we're going to call this book mass 2. And it is 1.20 kilograms, okay? And so what they want to know is that when he throws the ball, there is no friction between his feet and the ice pond, that his movement is going to go into the opposite direction, and this follows Newton's third law. For every action, there's an opposite and equal reaction. So the first thing to do to solve this problem is we need to find the mass of the man. Okay, so it gives us the weight equals mg, and we'll solve for the mass. 730 newtons divided by 9.8 meters per second squared. And that gives the man's mass 74.5 kilograms. So now, by using the law of momentum, the conservation of momentum, actually, m1 v1 must equal m2 v2. And so what I'm going to do now is I'm going to solve for V1. Okay, we know the mass of the man, we know the mass of the textbook, and we know the speed of the man throws the textbook in this direction. Okay, so let's solve for V1. This is m2 v2 divided by m1 equals v1. So now we just need to plug in our values into this. Mass 2 of the book is 1.20 kilograms. The velocity he throws the book is 5.0 meters per second, and this is all divided by the mass of the man. M1 is the mass of the man, and that is 74.5 kilograms. Okay, so this is solving for V1, so let's solve it. It comes out to 0.0805 meters per second. Okay, so now, since we have the velocity, we can find the time it takes the man. Once he throws it, he's going to move in the opposite direction. The pond is 5 meters, has a radius, so he's going to move this direction. So x is going to be equal to 5 in that direction here. So let's go ahead and solve for that. So we can use this equation, and we can solve for t. So t will be equal to the displacement divided by the velocity, 5.0 meters divided by the velocity of 0.0805 meters per second. And that gives us 62.0 seconds. So that is the answer to problem 59, chapter 6 on momentum.